In this video, I will be going through the filter content component and the related filters, excluding the text filters. All of these components can be found in the Rhino tab under the content section. As the name suggests, this component is used to filter content. The filter content has 3 inputs and 3 outputs. You need to input content to filter and a filter that you have constructed using the filters below. If you want, you can also put a limit on how many of the contents you wish to filter. By default, the limit is 1, so you need to remember to remove this input if you want to filter unlimited inputs. As an output, you get the filtered content. The second output will give us Boolean values depending if the content has passed or not, and count will give us the number of how many inputs were passed. The second row is what I would call the mathematical filters, which are less than, equality, and greater than. These are pretty self-explanatory. You're just going to input the value to compare against and a key, just like in many other components that are in the Rhino tab. For example, you can choose to use an user text attribute to test against. Then we have what I would call the programming filters. If you are familiar with coding, these are going to be pretty familiar to you already. You have the logical OR, NOT, and AND filters. And on the last row we have the intersection filter and union filter. These pretty much match the AND and OR filters, but allow for multiple inputs. We have old components that look very similar to the new ones, like equality, but with equality you could only compare numbers and you would have to construct a filter part yourself. And with the equality filter you can compare more types of data than just numbers, and you don't have to construct the filter yourself anymore. Let's go to some examples. On the right, I have a Rhino model with 3 buildings. The gray parts represent concrete and the lighter parts represent timber. I have assigned some user text attributes to the levels. So they have a building number and what level they are, top, mid, or ground, and all the levels have a price. I'm using the query model objects to get the content, and in the first I am constructing a greater than filter and comparing the user text price. So this filter will return true if the price is larger than 2500. I am then connecting the filter with the filter content component. The pass is going to give us the Boolean values for the objects which passed or which not. And the filter content tells us that 18 objects have passed the filter. And on the right I have a visualization. I have copied the geometry above the structure, and the green is what has passed the filter. Now if I were to put the filter to 5000, we would know that only the top floors cost more than 5000. Now if I connect the less than filter, I am only getting the floors that cost less than 5000. Now as I lower the price, even less floors are selected. You can always use the other output to get less than or equal. So now I am getting only the floors that cost less than 3000, and now I'm getting floors that cost less than or equal to 3000. And what is important to know about the less than filter is that as we're getting the error that the price is not defined on certain objects, that this filter is going to pass all of those. So I have not determined a price for the concrete columns, but I am getting them through the filter. Now in the last filter I have used the layer name as a test, and I am testing it against the value concrete. So when I connect the equal, I am only going to get things that are concrete, and if I'm connecting the unequal, I'm getting the things that are timber. And those were the mathematical filters. Let's move on to the programming filters. Now, if you have some programming experience, you're gonna know that this will return the opposite condition of the Boolean values. For example, I have now selected things that are not equal to concrete, which is the timber floors, and if I'm going to run this result through the logical not filter, I am going to get the exact opposite, which is the concrete parts. So you can think of this as a filter inverted Boolean component. Moving on to the logical AND filter. Now this filter checks if both of the conditions are true, and they both must be true for this component to return true. So now that I connect it to the filter content, it is going to check if the price is greater than or equal to 3,000 and less than 10,000. So this is the function for the filter, and we are getting the floors here. Now the logical OR filter will return true if any of the conditions, in this case either of the conditions, is true. So all of our floors will either fill the greater than 3,000 and less than 10,000 rule. The union filter and the intersection filter seem to work exactly the same as logical AND and logical OR, but they can take more inputs. The union filter matches the logical OR filter, their outputs are the same, and the logical AND filter matches with the intersection filter. I think the intersection filter is the more interesting of these two, because it will allow you to create more complex rules to exclude even more objects from the selection. Like here, I have chosen to include only concrete floors that cost more than or equal to 3,000 or less than 10,000. Now all of these components are a super useful addition to the Grasshopper toolbox and will simplify some things that Rhino has lacked